Hey guys, this is Hunter with Sonic Electronics, and today we have some exciting stuff to do. We have a bunch of lithium cells. These are SPIM 08 HPs, and we're going to be building a battery bank for our amp dyno test station. And how we're going to do that is we are going to wire these cells in series to get a final resting voltage of 14.8. Now normally these rest at 3.7 each singular cell, like this. This is 3.7. So we have each bank here. We have 6 cells in each bank. We're gonna wire them in series, and the resting voltage should be around 15, not 14.8, because of the fact these are actually all balanced at 3.8. And we're gonna link all these together with our Machineworx bus bars. Excellent quality, by the way. So we have our 3 linking bars, our 2 end caps, our spacers, our bolts for our power and ground connections, our nuts, end caps, and covers, our compression plates, and our threaded rods. So first thing I'm gonna do is put our end caps on our positive side and our negative side. And that will allow these to not move as much. Then we'll go ahead and do the bottom plates and then our middle plates. So this is gonna be an experiment to see if more expensive equals more better. Because normally with a 96 amp hour bank, so we have our cells, we have 6 cells in parallel in each bank. That would bring our amp hours up to 96 amp hours. Now, totally this bank is $444 before taxes. And if you want to go ahead and buy like a name brand excess power or name any of them, and they're gonna be at least twice as much for the same amount of amp hours and power and discharge rate. So yeah, this is mainly an experiment to see if these will actually hold up and they're reliable and they can output the power we need them to. All right, now we got our power connections on here. So what we're gonna do now is we're gonna put these in order. So positive, this side will be negative here, like so. Positive here again. Uh-oh. So what we're gonna do now is actually insert the threaded rods and the compression plates to make this a little easier, because our next bus bars are quite a bit bigger. So we're gonna get it all compressed with the threaded rods and install the other bus bars. So we're double checking, positive, negative, positive, negative. Just like that. So, if you guys notice, I did not go too far out here. That's because we're not entirely sure if this side here, the plate can go on and the nuts can go on easily. So we're just doing this as a precaution. So it looks like it'll be pretty easy here. So we have plenty of threaded rod on both sides to get these nuts on and everything secured. At this time, what we're gonna do is go ahead and get some wrenches and whatnot, compress this a little bit. I did forget actually, I need to loosen these up just a tidbit because you're not supposed to tighten anything down until it is compressed, just so it doesn't try to move the top of these cells like one way or another and you can damage the coating. And that's not what you wanna do with lithium, that is for sure. So let's get these loosened back up a little bit and then compress it, and we'll go ahead and finish her up with these other 3 plates. So the configuration with these plates is this one will sit here like so, connect this positive to this negative. Now I forgot to mention in the beginning of the video that you also need a balancer and a nice decent charger for these things. Variable chargers, the nicer ones, the DC power supplies. Then these other 2 plates will go here and here, and these spacers will go between each of those plates. All right. All right, now that we have the top all done and set, we're gonna torque them down later. We just use one of the lowest settings on our chuck here to get them set in there. Now, we're gonna start on the bottom. Spacer in here. All right, now the bottom's all done, torqued down pretty good. We're gonna go back through it with a ratchet and a socket, get them all nice and tight. Alrighty, so now we're here with our spin cell battery bank. So now we're gonna test the voltage. I did the math, it should sit somewhere between 15 to, so we're actually gonna have to discharge this a little bit because we wanna be around 15, 14.8. So this came fully charged. All these cells came fully charged, and so that's really good news. So let's go ahead and see what it is. So we got 15.34. Yeah, that's sitting pretty high. So we'll get some use out of it, drain it out a little bit, and then go from there once we get our balancer in here. So that should be coming any second now. So this is a balancer here. And how this works is you have your negative, which will connect to your main negative here. And this is our B2 positive, which will go here. Our B1 positive will actually go to this plate back here. B3 will go here on this back plate. It's hard to see, but we got some wires hooked up, so I'm not gonna turn it around. And then our main positive, which will be this red wire. So let's go ahead and get this hooked up, ready to go. Get that off there. So let's review this real quick. We have our negative, our B1, our B2, our B3, and B4 hooked up. And it shouldn't need balanced, but it looks like it is balancing slightly. Actually, no, it is not. So it just has power. When it says it's running, this light over here will turn on, I believe. The reason why you'll need an active balancer like this is because each section could charge or discharge at a different rate. So what this does is, let's say this is at 3.7, 3.7, 3.7, but this one's at 3.5. It'll take the juice from the rest of these three and balance it across the board to get it all equal to the nearest tenth, I believe. So they'll all be reading 3.6, 3.6, 3.6, 3.6 at the end of it. But right now, our resting voltage is 15.24. Like I said, that's a little high. For us, I should say. You can charge these up to 15.5, possibly even 16 volts, but that's not what we have this for. We're gonna be mostly running it at 15 volts for obvious amp dyno tests and stuff like that. We are going to top balance the secondary cell, which is going to our warehouse for our test bench. The way we're going to do that is they are all wired. They're going to be wired in parallel here. So all the positives are on top, all the negatives are on bottom. We're going to be using the same bus bars as what's on that one, but these are the 64 amp hour versions. But we just linked them together just so everything can balance. What top balance is let's say this one's 3.7 and then this one's 3.5 and this cell over here is 3.2. It will take all the energy from the cells and distribute it evenly across all of them. Otherwise, if one of these cells dies or a couple of them dies, the whole bank will die. And we don't want none of that. So we want everything to be perfectly balanced and before we even put on the active balancer. So let's go ahead and put these plates on. These ones. All right. Good enough. There's a slight resistance in here, I believe, but shouldn't cause too much of an issue for us. So now what you do is you just let it set for 24 hours or longer, depending on how out of balance they are. These weren't too far off, but we're just being safe. So that's it. So in conclusion, we have found out that this is the best bang for your buck budget DIY lithium. It does not really get much better than this. We have done a lot of research. A lot of people have told us to use these with a variable voltage DC power supply with these balancers, of course. And so if you guys like this video, please like and subscribe. If you guys want to see more videos like this, or if you guys have any ideas, put your comments below. And then if we can, we'll get to those ideas and go from there.